class. All right, I'm really excited that we get to continue working on our math unit even though we're not together. So we're going to try this digitally. That means either having a PDF copy printed up in front of you of what our classwork is, which is usually what we do. You just would be watching a video instead of seeing me in person. That's the easiest solution, but it's only possible if you have a printer. If you do not have a printer, I want you to have both the PDF and the video open at the same time. You've got two devices, easy peasy, one on each. If you have only one, split your screen in half, have the video on one side, the PDF on the other. At the same time, you need to have a piece of paper, line paper, blank paper, some sort of paper where you can write the answers as you go along. That's going to be your best way to keep track of what we're doing as a group, or virtual group, I guess, and so that you can keep track of your answers when you get to the part where you have to do the problem set at the end. If you have any questions about how to do it in your particular circumstance, let me know. I will help you. I'm sure your parents can also help problem solve. We'll figure it out. There is a solution out there. Right now, you should have the PDF, you should have the video, and you should be writing either on a piece of paper or on the PDF paper printed out. We're doing lesson number 7 from module 4. It should have this nice 3x3 square at the top where it says classwork and then example 1. So, example 1, our first question, what is the length of one side of this square? Easy. 1, 2, 3, 3 units. Done. What is the formula of an area of a square? Length times length, or length squared. That's the formula. You already know these things, right? That's one of the benefits of these examples. Sometimes you get yourself in, like, oh, I got this. All right, the next question, though, is what is the square's area as a multiplication expression? So in this case, we're looking at 3 units times 3 units, right? 3 units times 3 units. So then now what is the square's area? So we say 3 times 3, we know is 9. And now a lot of times you would say, well, it's 9 square units, right? You could also say 9 units squared. Both ways are fine. But it's important to know the reason it's a square unit is that we're not just multiplying 3 times 3. We multiplied 3 units times 3 units. So units and units are multiplied together too. So it's a square unit. I know it seems kind of crazy. Welcome to math. But I promise, the more you work with this, the more it's going to start making sense. All right, looking at the next part, it says we can count the units. Well, yeah, and I could count that there's 9, right? But let's look at this other square. Its side length is 23 centimeters. It's just too many units, tiny units, for us to draw. So what expression can we build to find this square's area? So in this case, when we're trying to figure this out, we're trying to make an expression super easy to do, because all we're going to do is say, well, what was the formula again? Length times length. And our length was 23 centimeters, so let's just insert that in. 23 centimeters times 23 centimeters. All right? Now we'll get to what is the area of the square. It says use a calculator if you need to. Well, isn't that fantastic? I'm going to let you pause right now. Pause the video. Great, so hopefully you just found the answer. The answer should have been, well, 23 times 23 is 529. But do we just leave it as that? No. Do we leave it as 529 centimeters? Nope. Still no. We are working with square centimeters, so 529 centimeters squared. This is super important. Always working with square centimeters or square units, units squared, inches squared, feet squared, because we're working with area. All right, let's look at the next, well, wait, sorry. You've got an exercise. So we're gonna pause the video and you're going to do exercise 1. Note that these drawings are not drawn to scale, so don't look at it and say, oh, I can figure it out just by measuring. It's not. So pause the video here. Okay, so hopefully you just answered exercise 1. And hopefully you found, well, you found 4 units is the length of the first square. And so then you found that the area written as an expression is 4 units times 4 units. And then you found the area was 16 squared units, right? Okay. And then the next one, the length was 25 inches. The square's area as an expression was 25 inches times 25 inches. And then the area written as a number is 625 inches squared. Hopefully that's what you got. So now we're looking at example number 2. Looks something like this, right? Yours is side to side, but similar thing. So for here, we need to use the formula A equals L times W. So area equals length times width. This is going to be a really efficient way to find the area of a rectangle without being required to count the area of units in a rectangle. So if we look at the first one, what does letter B represent in this blue rectangle? Mine's not blue, but what's the area of that rectangle? Or, sorry, what does B represent? We're not finding the area yet. What does B represent? B should represent 8 centimeters. Right? As we see B's here, B has this length here, and that length there is 8 centimeters. They have to be the same because it's a rectangle. All right, so now, given that this second rectangle is divided into 4 equal parts, we need to figure out what X represents. So it's 4 equal parts. Each part is 4 centimeters. Do you see that? So 4 centimeters, 4 centimeters, 4 centimeters, 4 centimeters. So in that X section, X covers 2 parts. So X has to be 8 centimeters. How did we arrive at this answer? So we figured out that the width of the 4 congruent rectangles, so these 4 rectangles here that are all the same size, they must have the same width. So 2 of those 4 centimeter lengths would be 8 centimeters. So what's the total length here? If I was trying to find the total length, I would find 4 times 4. We'd find 16 centimeters. If the 2 rectangles have equal lengths and widths, what's the area? So we'd have an 8 by 16 rectangle, right? Well, so let's do 8 centimeters times 16 centimeters. All right? 8 centimeters times 16 centimeters. Well, when you do that math, whether you use a calculator or you write it out by hand, you're going to find that the answer is 128 when you find 8 times 16. Again, though, what is our unit going to be? Centimeters squared. So that's super important that you're paying attention to that squared part of it. Okay, so remember that 1 letter, any letter, represents only one number. So whatever letter you're using, B or X or whatever letter, it only represents one number in an expression. When that number replaces the letter, the expression can be evaluated to one number. All right, you're going to do exercise 2. Pause the video while you work on exercise 2. Okay, hopefully you just finished exercise 2. I'm not going to tell you the answers this time because I think you should have it. If you do need the answers, just to make sure you're on the right track, let me know and I'll send that to you. Looking now at our final example, example 3. Looks something like this. Length, width, height, and then you've got 6 centimeters, 2 centimeters, 8 centimeters. So what does L represent here? Sorry, what does this L represent in the first diagram? That's length. What does W represent? Width. H, height. That makes sense. That's stuff you've done before, right? So notice that the right rectangular prism in the second diagram is an exact copy of the first diagram. So since we know the formula to find volume is V equals L times W times H, right? Length times width times height is volume. What numbers can we substitute for L in the formula? Well, here we would substitute with a 6, right? We'd have to. No other number can replace L. So the next question, what other number can we substitute for the letter L? Nothing. No other letter can represent that because L is this one here, 6 centimeters. Because we're only talking about this. Now, obviously, if our second diagram had different numbers, it'd be different. But in this situation, with just these 2 diagrams, only 6 can be here. So then, what about the W? Again, we have to go with what corresponds. So we've got this W that corresponds to the 2 centimeters, so that has to be a 2. And with that H, you have to be using the 8, H and 8, because they correspond. So I should have labeled these all centimeters, because when we figure out the multiplication here to find the volume, we're doing 6 centimeters times 2 centimeters times 8 centimeters. So 6 times 2 times 8, I already have memorized. I don't. But I do have the answer already. And that's 96. But it's not just 96. And it's not even just 96 centimeters. It's not 96 centimeters squared because we have centimeter times centimeter times centimeter. Centimeters multiplying by itself 3 times, so it has that exponent of 3. We call that centimeters cubed. 96 centimeters cubed is our answer. Okay, that's it for today's lesson. You're going to do exercise 3. If you need to check your work, let me know and I'll get you the answers. And then you're going to go on to the problem set. This is just like we do in math class every day. It shouldn't take too long, especially because you're just working on this. There's no interruptions. So, hopefully, this all makes sense. If it doesn't make sense, let me know. We can either arrange a way for us to speak, or I can answer a question really quickly by email. If you need help, just let me know. That's my job, and I am always eager to do it for you. All right, have a great day, guys.